Greetings of the day to all. I, Ina, am Assistant Professor, CSC, School of Engineering at DSU. Welcome you all for distinguished guest lecture on higher education opportunities in computer science at IISc and beyond by Professor Y. Narahari, Professor of CSA, Indian Institute of Science, Bengaluru. Higher education avails to you an opportunity to pursue a career of interest that also inspires you. Higher education offers
Madam, we lost you.
Hello.
Yeah, I think we lost.
Yeah.
Video.
I will introduce Narahari, sir.
Yes, sir. Yes, sir. Girish, you can take over and continue.
Yes, sir. Yeah. Good evening to everyone. It is a great honor for me to introduce Professor Y. Narahari. We are pleased to hear from such a highly learned and accomplished researcher. Professor Y. Narahari is currently a professor at the Department of Computer Science and Automation, Indian Institute of Science, Bengaluru. The common thread in his current research is to apply game theory, mechanism design, and artificial intelligence techniques to research problems at the interface of computer science and economics. In particular, he is interested in actions and markets, cooperative game theory, computational social choice, machine learning, and data analytics. He is also exploring the application of these to digital agriculture and public health problems. He is the author of textbook entitled Game Theory and Mechanism Design, brought out by the IISc Press and the World Scientific Publishing Company, and a co-author of two other highly cited books. Please join me in welcoming Professor Y. Narahari to address all of us on the topic higher education opportunities in computer science at IISc and beyond. Over to you, sir.
Thank you, Dr. Girisha, and thank you, Professor Murthy. It's a wonderful opportunity for me to be talking to students, young students, and also faculty members from many institutions in Bangalore who are interested in higher education opportunities in computer science in the Indian Institute of Science and also beyond. So I think this is a nice opportunity for me to talk about my department, my institute, and also in general about computer science, education, higher education opportunities. I just want to know whether the screen is completely visible to you. Is there something else that I need to do so that the screen is
is perfectly visible, sir.
It's completely visible, right?
Yeah.
You don't see any other spurious things here?
No, nothing.
Excellent.
Hello, sir.
Yes.
Sorry for the inconvenience, sir. I had a
no problem, madam.
Yes, sir.
No problem. Yeah.
Thank you.
So I have actually started my presentation now.
Yes, sir. Yes, sir. Thank you.
Yeah, sure.
Sorry for the inconvenience.
Absolutely no problem at all.
Yes.
So this is going to be a lecture where I will give a brief overview of the Computer Science and Automation Department, the EECS division, Electronics, Electrical and Computer Sciences division, and also IISc. And then this lecture may go on for about 25 to 30 minutes only. I would like to take as many questions as possible from aspiring young students. Okay, so let me get started with an introduction to the Indian Institute of Science. All of you would be knowing that this is now a 113-year-old institution, which was established in 1909. It is an outstanding example of a public-private partnership in the Indian education scenario. And the inspiration for the setting up of the institution was provided by none other than Swami Vivekananda. The main architect for the commencement of this institution happens to be Jamshedji Tata. And he was the one who was able to envision a grand research university. And, the motto that he set forth was to provide for advanced instruction and to conduct original investigations in all branches of knowledge and in particular such branches of knowledge as are likely to promote the material and industrial welfare of India. So you can see the keywords here, the material and industrial welfare of India. And the Maharaja of Mysore, of course, played an extremely important role in the setting up of this institution. The institute has contributed significantly to several national programs. For example, the Indian Space Program and the Indian Atomic Energy Program basically can be attributed to some of the luminaries who worked in the institute, namely Professor Vikram Sarabhai and also Professor Homi Bhabha. So they have very deep connections with the Indian Institute of Science. More recently, the light combat aircraft and the missile development program and also the Mars orbiter mission has benefited greatly from association with the Indian Institute of Science. IISc has also incubated major institutions. The Tata Institute of Fundamental Research was essentially born in IISc. The high-tech company Wipro was born in one of the labs in the Computer Science and Automation Department, and institutions like Central Power Research Institute and the Jawaharlal Nehru Center for Advanced Scientific Research and many other institutions essentially were incubated at IISc. The first IIT, namely the IIT Kharagpur, was established mostly by the professors of IISc. In fact, Professor J.C. Ghosh, who happened to be the director of IISc, actually also became the first director of IIT Kharagpur. And in fact, many of the first directors of the first 6 IITs happened to be professors from IISc. So IISc is a comprehensive university. It has 6 divisions to it. There are 3 divisions in the sciences and 3 divisions in engineering. The 3 divisions in the sciences are chemical sciences, biological sciences, and physical and mathematical sciences. And then we have 3 divisions in the engineering sciences: mechanical sciences, EECS, and interdisciplinary research. So these are the 6 divisions of IISc. And what has been included here are the various departments constituting these 6 divisions of the institute. And more recently, IISc has taken a historic decision to set up a medical school also. Now, in terms of faculty distinctions, it turns out that IISc is the single institution which has the largest number of decorations such as Bharat Ratna, Padma Vibhushan, Padma Bhushan, Padma Shri, and the SS Bhatnagar Prize, as many as 96 Bhatnagar prizes from IISc faculty. And also in terms of fellowships of the Indian Academy of Sciences, Indian National Science Academy, National Academy of Sciences, and the Indian National Academy of Engineering. In terms of international recognitions, the division of EECS has 9 IEEE fellows. The institute has 6 Infosys Prize winners, and there are various international fellowships that the faculty of the institute have been conferred with. Now, let me now focus my attention on the division of EECS, Electrical, Electronics, and Computer Sciences. It is made up of 4 departments: Computer Science and Automation, to which I belong. Then ECE, Electrical Communication Engineering. This is the department in which I did my undergraduate program. Then the Department of Electrical Engineering and the Department of Electronic Systems Engineering. So these are the 4 departments in the division of EECS. Whereas more recently, the research in the division is also conducted in terms of the research clusters. This is essentially to promote collaborations among the faculty members belonging to the department, the 4 departments in the division, and also the departments across divisions in the institute. And so we have a research cluster on brain computation and data, then a research cluster on cyber physical systems, of course, AI, in the area of AI, we have almost like 40 faculty members working on different aspects of AI and machine learning. Then we have a cluster on cyber security and a research group on visual analytics. Then power engineering, which consists of power systems, then power electronics and high voltage engineering. And we have a major 5G testbed project and a very lively group on microelectronics and VLSI design. And we have a research cluster on data storage. And more recently, the Institute has put together a major initiative on quantum technologies. And in all of these research clusters, the faculty of the division of IISc and also the faculty of CSA play a very important role. Now, from IISc to EECS division, I now come down to the Computer Science and Automation Department. Professor Dikshitilu was the founding chair of the department, 1969. And as the founding chair, he set up the department with assistance from the government of India and also the Russian government. And he later on became the director of the National Remote Sensing Agency. And then in 1971, Professor I.G. Sharma took over as the chair of the department. And 2019, the department actually celebrated its golden jubilee. And we actually, in memory of Professor I.G. Sharma, we have an I.G. Sharma Memorial Lecture, which is actually delivered by luminaries in computer science. For example, the 2015 lecture was given by the Turing laureate, Silvio Micali, and the 2017 lecture was given by Christos Papadimitriou. Then the department itself has research clusters. There are three major groups in the department. So one is theoretical computer science, which is essentially algorithms and complexity theory. Then we have computer systems and software. And then we have another group on intelligent systems. And the broad topics which are covered by these groups are security, in particular cyber security, then cryptography, then cyber physical systems, software engineering and programming languages, then reinforcement learning, machine learning, blockchains, databases, algorithms, and so on. Now, going on to different research streams, the research stream on theoretical computer science has all of these faculty members who are listed here. And the broad topics which are pursued here include algorithms, then random projections, foundations of data science, complexity theory, cryptography, computational geometry, automated verification, graph theory, and geometrical algorithms. So you can see that there's a wide spectrum of theory topics which are pursued here. And then in computer systems and software, topics like power-aware computing, storage systems, programming languages, distributed computing, compilers, database systems, cybersecurity, multi-core programming, software engineering, and scientific visualization are pursued. And the group on intelligent systems pursues topics like game theory, data mining, deep learning, e-commerce, machine learning, mechanism design, reinforcement learning, social networks, stochastic control, and cognitive systems. So you can see that a broad spectrum of areas are covered by the department faculty. We have 33 faculty members in the department, and these 33 faculty members are, they have graduated from leading universities in India and also the entire world. For example, we have faculty members who have graduated from IIT Kanpur, IIT Bombay, IIT Madras, TIFR, IISc, and then from Stanford, Duke, Georgia Tech, Wisconsin-Madison, Max Planck Institute, Technion, Princeton, Caltech, Berkeley, Illinois, and so on. And the CSA faculty members, have earned many distinctions. 3 of them are IEEE fellows, 2 of them are ACM fellows, 4 of them are INSA fellows. So these are all fellowships of the academies. And in terms of prizes and honors, you can see that as many as 24 of the faculty members have been conferred the Young Scientist Awards of the various academies in India. And as many as 19 faculty members have got industry faculty awards. So these are research awards which are given by global corporates such as Google, Amazon, Microsoft, Adobe Research, Qualcomm, and so on. Also, more significantly, as many as 18 faculty members happen to be on editorial boards of leading journals in computer science area. In terms of research publications, the faculty publish more than 100 publications, and a majority of these publications are in top tier fora. In computer science, many of you may be knowing that there are very prestigious conferences where publishing in those conferences is considered as prestigious as publishing in some of the top journals. In fact, some of the conference publications are considered even higher than some of the leading journals in the area. So it turns out that of the 100 plus publications per year, a majority of them, 60 to 70 publications, are in these A plus publication venues. One paper on data clustering, which is authored by Professor Narasimha Murthy, has as many as 18,000 citations. It's a paper on data clustering, which was written in 1999. And to this day, it has already garnered more than 18,400 publications. And there are many best paper awards that the papers have received. For example, the most influential paper award in this Programming Languages Design and Implementation Conference is a prestigious award, ACM SIGSOFT Distinguished Paper Award, and any number of best paper awards in international conferences. Now, I can say very proudly that the CSA faculty have published papers in some of these venues that are listed here. For example, Stock and Fox. So Symposium on Theory of Computing and Foundations of Computer Science. So these are, for example, supposed to be two premier conferences in theoretical computer science. And all the publication venues that are listed here, these are the very top publication venues in theoretical computer science. So whereas the venues that are listed here, all the way from ICD to hot storage, so these are very coveted venues in computer systems and software area. And finally, in AMAS, in intelligent systems, you have conference venues like AMAS, NeurIPS, ICML, UAI, ICDM, and so on. And all of these are venues where publishing is considered as a big achievement. And it turns out that the faculty members from CSA have published the first papers in many of these publication venues, the first papers from India in many of these publication venues. And as I already told you, 50 to 60 publications per year happen to be from these venues every year. In terms of teaching and research programs, and this is something that is going to be of great interest to the prospective young students here. So we have an M.Tech program in computer science and engineering. This is easily the India's flagship computer science and engineering program, which attracts the best talent. The gate toppers actually join this program. Then we have an M.Tech in artificial intelligence program. IISc was the first institute to start an artificial intelligence M.Tech program 3 years back. And the uniqueness of this program lies in the fact that this program is offered not only by computer science and automation, but in collaboration with the other 3 departments in the division of ECS, namely the ECE department, the electrical department, and also the electronic systems engineering department. This shows the interdisciplinary character of the artificial intelligence area. And we have recently introduced an MTech AI online program, which is absolutely equivalent to the in-person program that we have. But the MTech AI online program is actually for working professionals. And the first batch of students has already joined. And it turns out that this is turning out to be a very successful program. We have a very distinctive program called MTech Research. Now, the MTech Research program is an approximately 2-year research program where the students actually do a thesis work, and the degree is awarded based on the quality of the thesis work. They do the essential courses which are required for the research work, whereas the MTech Computer Science and Engineering and MTech AI programs, these are course oriented. You do a fairly large number of courses followed by a 1-year project, whereas the MTech Research program is more like one full semester of coursework followed by almost like 3 to 4 semesters of research work. So, and then finally we have the PhD program, which is for IISc PhD program is the most important program. In fact, 60 to 65% of students in IISc happen to be PhD students. And in CSA, we have as many as 80 PhD students who are all full-time PhD students working here. So in terms of the number of students in the various programs, it turns out that in PhD, we have a total of 84 students, of which 64 happen to be male and 20 happen to be lady students. Then in MTech research, it's more like 29 plus 10. In the case of MTech total, it is 152 plus 28. So totally we have 245 plus 48, 303 students. So in some sense, in terms of the number of students, as you know, IISc is a postgraduate institution. So in terms of the number of students, I am in IISc, the Computer Science and Automation department turns out to be the largest department. And now we are striving our best to increase the number of female students in the institute in general, and also computer science and automation in particular. And hopefully the number of female students will increase significantly in the years to come. In terms of student recognition, it turns out that most of the PhD fellowships given by Google in India are bagged by the computer science and automation students, and Google Women in Engineering awardees, and then IBM PhD fellows, MSRI PhD fellows, TCS PhD fellows, and the Prime Minister's Research Fellowship fellows. In fact, a couple of the PMRF students are actually teaching courses at the Dayanand Sagar University. Both of them happen to be my students, Sri Durga and Anand Krishna. As a part of their Prime Minister's Research Fellowship program, they're actually supposed to teach a course or conduct a research workshop in a semester. And all the PMRF fellows in the institute actually are engaged in offering classes in mostly the Bangalore colleges. And this is something that provides excellent exposure to the PMRF fellows. And many of the students, get best paper and poster awardees. Let me mention that many students actually co-author publications without a faculty member being a co-author. So there is freedom in collaborating with the other students and other faculty members. And there are many papers where only students happen to be the authors of these papers. And in terms of recognitions, I must mention the ACM India Best Doctoral Dissertation Prize. It's a very prestigious. This is the most prestigious prize for a PhD thesis in computer science in India at this point of time. The 2017 award was won by a student called Palash Day, and the 2021 award also was won from CSA, and also an honorable mention in 2016. And in 2021, at the All India level, the INAE Doctoral Dissertation Award was won by Arpita Bishwas. So the students also have distinguished themselves very well here. And in terms of collaborators for the department, you can see that the faculty members and the students of the computer science and automation, they collaborate with faculty members and students of all these universities which are listed here, all the way from the Massachusetts Institute of Technology to Technion, Harvard, Berkeley, and also there is a fair amount of interaction with institutions in India, IIT Bombay, IIT Madras, CMI, Indian Statistical Institute, and TIFR, and so on. Not only that, the research that is conducted here is also sponsored by almost all the corporate giants who are located in India, all the way from IBM, Infosys, Microsoft Research, Google, and so on. So, and government funding agencies like the Department of Biotechnology, Department of Science and Technology, SCRB, and so on. So you will see that both public funding agencies and corporate funding agencies are liberally supporting the research that is happening in the department. And many of the students actually spend internships in these companies. We strongly encourage 3-month to 6-month internships for our PhD students and also master students. And many of the students get excellent exposure by spending research internships at all of these institutions. CSA more recently has also been very active in deep tech entrepreneurship. For example, the Simputer basically, was born in a lab in CSA department. As I told you, Wipro Information Technology itself was incubated in one of the labs in IISc way back in the early 1980s. And Strand Life Sciences, which today happens to be one of the leading bioinformatics companies, again, was incubated at IISc. So 4 faculty members, Professor Vijay Chandru, Professor Ramesh Hariharan, Professor Vinoy, and Professor Swami Manohar, they launched both the Simputer company and also the Strand company about 15 years back. And the department has not looked back ever since. I have already told you about Wipro starting here. And more recently, in the last few years, there is a deep tech company, Polymage Labs, Professor Uday Kumar Reddy. This is a deep tech company which designs, implements compilers for artificial intelligence, and a company called Mimic, which is a virtual reality based company for endoscopic simulations. So the department itself has been actively involved in deep tech startup companies. Let me now present to you a few problems that I have been working on in more recent times. For the past 2 years, I have been interested in how AI, ML, and game theory can be used for helping the small and marginal farmers in the Indian agriculture ecosystem. And we are working on 3 or 4 problems here in collaboration with the National Bank for Agriculture and Rural Development. So in some sense, this is an AI for social good kind of a project where we're trying to use our expertise in AI, ML, and game theory for a problem on the ground. For example, one use case that we are looking at is, can we predict the yield and also the price of an agricultural crop accurately enough so that we will be able to help the farmers in planning the sowing activity, also deciding when to harvest, and also enables the government to plan in a better way about agricultural policies. So if we are able to predict the yields and prices in a fairly accurate way, the uses for which such predictions can be used have a vast scope. Essentially, what we do is to use historical data, supply side factors and demand side factors, and sophisticated ML, machine learning and deep learning models in order to come up with these predictions. And you would know that this is a grand challenge problem in agriculture. It's not an easy problem at all. You may be able to solve it accurately for some crops, but not so accurately for other crops. And turns out that the data quality and demand side issues are also very major issues here. And we are trying to look at this problem from a fundamental viewpoint and see whether we will be able to come up with more accurate predictions than available in the state-of-the-art literature. A related problem that we have been looking at is whether we can also use some of these techniques in order to recommend the best crops that the farmers can grow in the next 1 year. It turns out that traditional factors and also the so-called best practices followed by the farmers from age-old days, take priority over scientific decisions in trying to decide what crops to grow in a given season. So as you know, there is a Rabi season, there is a Kharif season, there is an intermission between the Rabi season and the Kharif season. And depending on the soil type, depending on the expected climate conditions, and depending on so many local factors, it is actually possible to come up with an optimal way in which crops can be grown. You can actually recommend an optimal crop or a portfolio of crops to the farmers. So crop portfolio recommendations for the entire year is a problem that will hugely benefit the farmers. Of course, the main challenges here are climate variability, demand export uncertainty, and cultural factors, and so on. So our conviction is that if we are able to do this crop recommendation in a convincing way to the farmers, it will be a game changer if we can convince the farmers with explainable models. And so this is another direction in which we are trying to do the work. Finally, I think agricultural markets are a very important problem. Game theory can play a very important role in designing market mechanisms which are very fair and which also take into account the aspirations of the farmers in the best possible way. And so we are trying to use our expertise in game theory to design markets that are attractive to farmers and consumers. And just today, for example, I visited a farmer producer organization, which is actually present in a place called Rajghatta near Doddaballapur, about 40 kilometers from Bangalore. And this is an FPO, a farmer producer organization, which engages with about 1,000 farmers, about 1,000 small and marginal farmers. These are farmers who have less than 5 acres of land. About 1,000 of them in a radius of about 7 to 8 kilometers around Rajghatta have come together, and they want to do agriculture in a cooperative way. And so there is an FPO. So this is a coordinating agency which tries to coordinate both the input side and the output side for the agriculture ecosystem for these 1,000 farmers. So we were trying to study how this organization is working and how such organizations can be improved using technology and using, for example, data-driven techniques, right? So I think, so this is one project which has a huge potential, but again, it's a grand challenge problem, and implementation is not going to be easy at all. There are so many factors that need to be taken into account, but AI, ML techniques and data analytics techniques have a lot to offer in this area, and I think there is a need for exploring the use of such models in applications like this. To give you an example, one of the things that an MTech project student of mine is doing is to go to tomato farms, then mango groves, and take video pictures And based on an analysis of these video pictures, the student is able to do the quality assessment or the grading of these tomatoes, or let's say pomegranate, and also do an yield prediction. And some of these things will be extremely useful to the farmer and also for the financing agencies to decide on the amount of credit and so on. So what I have tried to present in the last 4 slides are certain use cases in an application like agriculture, which can be impacted by computer science techniques. And like this, I think in public health problems, for example, during the past 2 years, the department faculty have actually done a fair amount of work in COVID modeling, and also in coming up with various tools and techniques by which diagnosis could be done, and also prevention could be done, and also scheduling of vaccinations and so on. In addition to that, there are a large number of projects being done in areas like healthcare, and of course there is a fair amount of deep theoretical work on very important problems in computer science at the global level, which are currently happening in the department. So this is in some sense my last slide. The department itself is pursuing excellence in research, education, and innovation. So cutting edge research, very rigorous coursework, and deep tech ecosystem. And I think there are opportunities aplenty in the department. And here is a web page which will give you more details. I'm going to share this presentation with Professor Murthy, and you will be able to take a look at this presentation. So in some sense, I have come to the end of my presentation now. What I have essentially told you is about the computer science and automation department in particular, and the division and the institution in general. Let me conclude by saying that this is a department and an institution where there are lots of opportunities for higher education for computer science students, right? There are many other institutions, and of course many other institutions across the world, where all of you young students will be able to pursue opportunities of various kinds. What I would like to do is, instead of presenting a very broad overview of what are all the other opportunities which are possible for you, I will be very happy to take questions, and then through your interaction I will be able to give you more information about what kind of higher education opportunities are available in computer science in IISc, beyond IISc, and also abroad. So with this, again, I would like to thank Professor Murthy and Bytes organization for arranging this talk. And I'm very, very happy to take questions from the young students who are assembled here, and also from the faculty members. I will now stop sharing my presentation.
Thank you, sir.
Yes.
For educating us on the glorious achievements, recognitions, and the opportunities in the electrical, electronics, and computer science domains at IISc. Myself, Mukti Chaturvedi. I'm assistant professor in the Department of ECE at DSU and Vice Coordinator. So with your talk, we've also got an idea of the scope of prediction science in basic life scenarios of agriculture and medical sciences, as you just mentioned about. So taking up some of the offline questions that I've received. So the first one, the very, very basic one, to get an understanding of the scope of AI and ML. So we know that in general, the data science has a blanket cover over all the domains, be it computer science, be it manufacturing, basic sciences, and whatever we can think of. So how far do you see this to be the trend, so that the educational institutes can completely, or to what extent can educational institutes divert the focus to data sciences?
Okay, so this is actually not a simple question. It's a very interesting question, I would say. Data science now pervades across disciplines.
Right.
In fact, in the institute, realizing the importance of data science, there is a separate department also called the Computational and Data Sciences Department. And so data science, as a discipline is pursued not only in the CDS department, but also in various departments across the institute. I was talking about a research cluster called AI. It's a very broad cluster. Now, the AI cluster actually includes artificial intelligence, machine learning, deep learning, data science, data analytics, and all of these, which can be broadly classified under AI and data science. As I already said, there are 40 to 45 faculty members in the institute working in different aspects of AI, ML, and data science in the institute. And this cuts across not only the 4 departments that I mentioned, but also departments like the computational and data sciences, the Robert Bosch Center for Cyber Physical Systems. There is a Center for Infrastructure, Transportation, and sustainable urban planning and sustainable transportation. And then we have the Center for Neuroscience. Then we have the Material Science Department, Materials Research Center, and also the Department of Physics. It turns out that in all these 11 to 12 departments, now data science as a theoretical discipline and also as an application discipline has come to play an extremely important role. So when we started the MTech AI program, so one of the fundamental deviations that we did in the institute was usually an MTech program is offered by a single department. For example, we have the Computer Science and Engineering MTech program, which is a flagship MTech program in the computer science. Then we have Communications and Networks, which is a flagship MTech program of the ECE department. But when we launched the AI program, we saw that AI program has an influence much beyond computer science. So this is now a division-wide program where computer science and automation, electrical communication engineering, electrical engineering, electronic systems engineering, Robert Bosch Center for Cyber Physical Systems, they're all collaborating to offer this program as a joint program. So there is no going back on AI, data science as technologies that are going to drive many important applications which have implications for society at large. So it's very important. I would also like to say in the same breath that foundations of data science are very important. So when I talk about foundations of data science itself as a discipline, right, has several layers to it. Now, at the lowest level of abstraction, you have the foundations. Right. So these are actually the mathematical foundations. Exactly. These mathematical foundations are constituted by probability and statistics, linear algebra, right, analysis and optimization, graph theory, algorithms, complexity theory, and so on. So these are the basic foundations. Now, in the next level, you have tools and techniques. The tools and techniques could be data structures and algorithms, right? And it could be parallel algorithms. So these are all the various tools and techniques. And it could be, for example, disciplines like pattern recognition, image processing. So all of these disciplines and tools and techniques, they actually use the math foundations which are there at the previous layer. Now at the next higher layer, you have all the platforms. See, when you have a very powerful machine learning application, it has to actually run on a platform. This has to be a scalable platform. So you have multi-core computers, you have parallel machines, right? And then you also have algorithms which can run on some of these highly scalable architectures and so on. So the architectural issues, the platform issues, the cloud computing issues on which all these machine learning data science programs will run will form the next higher layer. And the final layer is the application layer. You may have an agriculture application, you may have a cybersecurity application, or you may have a healthcare application. All of them now will have to run on these platforms. So all these 4 layers are very important for data science. And I must say that at IISc, while there is focus on layer 2, layer 3, and layer 4, there is emphasis on layer 1, which are the math foundations, right? So most of the MTech programs and PhD programs try to focus on layer 1.
Right. Yeah. So this was very important for us to hear this from you and for the students as well, because this makes it very clear that wherever we are targeted to whichever domain in AI and ML, we cannot be ignoring the basic foundation courses.
Absolutely.
Everything builds upon that. Yeah. So that's very important for all the students attending this session to be knowing very well. So okay. So coming to next question, we have. So how do we motivate students towards this domain and appropriately towards the industry? How do we make them in this industry ready?
So when you say domain, what is the domain that they're talking about?
Again, I think the data science itself is what is the question.
So it looks like there's an obsession with the data science, so which is good. Okay, so the motivation is the following. The basic techniques of data science have been there for 40, 50, 60, 70 years. There is a discipline called operations research, which all of us know. There is a discipline called, algorithms and complexity theory and so on, graph theory and combinatorial optimization. So these are all areas which have been there for 40, 50, 60 years. Now, data science and also artificial intelligence are basically building upon these math techniques which have been developed over a long period of time. There are 2 things which have made a difference in the last 10 years. The first thing that has made a difference is the availability of data in huge quantities. And these could be healthcare data, this could be factory data, it could be, for example, agriculture data. So now a huge amount of data is becoming available. And this is real data. Of course, the data itself could be very noisy. And people have figured out ways and means by which noisy data also can be cleaned up and curated. So on the one hand, you have huge amount of data that is becoming available to you. There is also the realization that if you do intelligent data analytics, if you're able to analyze this data, there are certain inferences that you can make from this data, which have significant implications for your business itself. And that realization also has been there because of advances in recommendation systems, data mining, and so on, right? So this is one aspect of it. The second aspect of it is, if you have a large amount of data and then you want to do data analytics and then you want to do inferences, then you will also need algorithms for that. And these algorithms also will have to run on computers. And many of these algorithms happen to be NP-hard algorithms, or they have a tremendous amount of computational complexity. Now, if you want to run these algorithms, you also require powerful computing platforms. So what has happened in the last 10 years is also availability of a huge amount of computing power. It could be in terms of multi-core computing, or it could be in terms of parallel architectures and so on. You also have enormous amount of computing power at your disposal. So you have huge data, you have computing power, and you have algorithms which can infer a lot of useful things by doing data analytics on this data. This has actually become a game changer. And so because of this, data science as a discipline is going to stay for some time. And so the motivation for getting into data science is the fact that almost every aspect of human life is driven by some kind of a data, and possible to come up with enhancements to the way things can happen in each one of these applications by using intelligent data. I think that should be the motivation. And many of these applications also turn out to be social good applications. So these are societal applications where the society at large is going to be benefited. To give you two examples, one example is Bangalore traffic. Everybody knows about Bangalore traffic, how smooth it is and how unpolluted it is. Everybody knows about Bangalore traffic. Now, if data about Bangalore traffic is also becoming available. So if you can actually analyze this data and come up with certain strategies by which the traffic itself can be smoothened, right? That will be a great contribution, and data science actually can contribute to that. The second application, which is in some sense closer to my heart, is agriculture. It turns out that 85% of the farmers in India are small or marginal. Small farmers are those who have less than 2 acres of land. Marginal farmers are those who have less than 5 acres of land. And if you look at the plight of the small and marginal farmers, and if you can do anything that will improve the state at which they are currently in, it will be a huge benefit. And it turns out that, again, there is a plenty of data available. It is just that one has to look at what kind of data is available and how we can leverage the data using fairly sophisticated models, and then come up with inferences, and finally make up some simple mobile apps that the farmers can use, which will help the farmers to get the inputs properly and then also be able to market the outputs directly to the consumers rather than going through several layers of brokers and middlemen and so on, right? So I think there is an opportunity for data science, AI techniques and ML techniques to change the way life itself can be improved, right? What other motivation do you need other than this to be able to work in this area?
Yes, this connects it so well, connects us, all of us so well with the society and the needs of the times. Definitely. Yes. So the next one, so as we understand completely that it is data that is critical for any analysis that we want to do. But further on, when we use this data, now the way in which the accuracy of the predictions can be adjusted by varying the various hyperparameters in the different ML techniques. What is it that ensures that the predictions really represent the actual scenario?
Okay, so this is a very interesting question, right? And this is what we grapple with when we start, doing analysis of the data. I can again take the example of agriculture. Fine. So what we have found is that you can work with the most sophisticated models. For example, for crop price prediction, we are trying to use fairly sophisticated models. These are deep learning models, right, which use convolutional neural networks, recurrent neural networks, graphical neural networks, and so on, graph neural networks, and so on. So you may use very sophisticated models. Now, if the data itself is not good, then the predictions that you are going to get will be way off the mark. Fine. So there are many things that need to be done before you start applying these math models. First thing is curation of the data. You look at the data, look for outliers, and use various scientific methods which are available in order to clean up the data and come up with a data set which in some sense fairly accurately reflects the actual data. There are techniques available for that, but there's a lot of hard work that needs to be done there. This is the first thing. Second thing is, so the person who is asking the question has also mentioned about hyperparameters. These hyperparameters are also very important because these are parameters that you need to sort of fix before you actually run the machine learning model. Now, hyperparameter optimization itself is a fairly intensive research area. So you need to talk to domain experts, right? You need to design experiments. You will have to do intelligent experimentation in order to do hyperparameter optimization. There are various scientific techniques that have emerged for hyperparameter optimization also. So, and there are various ways of figuring out whether the model is producing correct results or not in terms of the performance metrics, right? So you have to be very clear what performance metrics to use for which application. For a given application, a certain type of computing the error may be extremely relevant. Whereas for a different application, the same technique of computing the error may be a horrible way of computing the error because the performance metrics for the other application are very different. So all of these things like data cleaning, data curation, hyperparameter optimization, all of these will have to be done properly and correctly before you actually apply the math models.
Right.
And it turns out that, there's so much of research work done on math models. That's a solved problem. You don't have to do anything more there.
Mhm.
Better look at the quality of the data. You better look at hyperparameter optimization. Prepare everything that is required for applying the math model itself.
Right. Yeah. Get it. So basically I relate very much to this question also because I actually do not belong to CS domain. I am doing research in manufacturing and electronics domain, and I try to use data analytics for a small part of manufacturing technique that I'm working on. So I did come across this problem where while learning, I understood that to get reduced error function, we can play around with the hyperparameters. But yes, as you said, there's a lot that needs to be studied before we do that.
You should be very careful in choosing the error function also.
Right.
Because an error function which works for a particular application may not work for a different application.
Exactly. Yes. Right. So now at this point, taking advantage of having a chance to talk to you directly as part of this session, so I would want to ask that what are the possibilities that students and research scholars, including me in this scenario, can utilize the facilities at IISc for this domain, data domain, and also for testing and characterization studies. And if there is a possibility, how can we take this forward?
Sure. So testing and characterization, we have, fairly sophisticated equipment in IISc. And, if you want to do testing and characterization, especially in the areas of microelectronics and nanoelectronics, right?
Yes.
So there is a portal where you can get into the portal. It's called, I think it's called a STEM portal or something.
ISTEM.
ISTEM. You're right. And so the Center for Nanoscience and Engineering, the Materials Research Center, the Materials Engineering Department, they all have these facilities, right? So ISTEM is one portal that you can certainly, leverage. And if you happen to know the faculty members who are working in these areas, right, just send them an email with a proper subject header, right? If the subject header is not proper, the faculty members may not even look at the email. Choose a subject header which will catch the attention of the faculty members, and faculty members, when they see an email from young researchers or students, 99% of the time we reply immediately, right? So that's one way. Whereas with respect to data related things, CSA department, CDS departments, we have fairly sophisticated computational facilities, right? And one of our charters is to help out colleges in the neighborhood, right, to be able to use these facilities. The best way to do that would be to send an email to the chair of the department. All that you have to do is to go to the website of the Computer Science and Automation Department or the Computational Data Science Department, right? And you can take a look at what are the computational facilities available in the department. If you want to use those facilities, send an email to the chair of the department. They will find a way by which you will be able to use the facilities. In fact, when we get the funding for many of these computational facilities, there is a program called FIST program. So this is a fund. This is a fund that is given for infrastructure in science and technology. This is by the Department of Science and Technology. One of the objectives of FAST is to set up sophisticated computational and infrastructural facilities and equipment in leading departments, and also make those facilities available to the local ecosystem. So you all belong to the local ecosystem. Please feel free to contact the chairs of the departments. And I am always there. So I can always direct you to the right person, right, who should be contacted for using some of those facilities. We will make it happen.
All right. So we understand that reaching you or reaching IISc for any opportunities is just an email away. So we will definitely do that. So the students and faculty, what I understand is would be equally looking forward to any possible learning collaboration with IISc, which may turn out to be on the steps of the IT giant Wipro or to maybe even unknown limits. So thank you from all of us at DSU, and I would now request Professor.
Madam, Mukti Madam will ask Professor Natarajan for his,
all right.
his remarks. Yeah, Professor Natarajan, sir.
Yes, Murthy, I am available here.
Yeah.
It has been a tour de force of all the facilities and the expertise that is available in the Indian Institute of Science. All of us have a lot of respect for IISc because it is the topmost research institution, also recognized by the entire world. If you're talking about research in science, technology, R&D, and innovation, IISc is the first name that comes to our mind. There are a few lessons that I have learned from what I have listened to Professor Narahari. First of all, you need a critical mass of experts, of researchers, of innovators, in order to make things happen. And IISc has gathered together this kind of a critical mass. In one section of a department of a division, they have 45 experts working on problems which are congruent with the societal needs. Secondly, you need leadership to direct the efforts of this group towards the solution of societal problems. And he has also pointed out that there is a whole series of layers, starting from theory and foundations to applications to solve relevant problems of our country, agriculture, health, and things like that. Therefore, all of us have respect for this institution, which was started early in the 1900s. And I am an alumnus of Indian Institute of Science. I was a student of power engineering. And there is an alumni association which also promotes the activities that BITES is doing. I would like to congratulate Professor Murthy for thinking of these distinguished lectures in order to make available to a wide cross-section of interested academics what is available in our own city. Congratulations to Professor Murthy and of course to Professor Narahari. Thank you very much.
Thank you, sir. Thank you.
Thank you.
Yes, thank you for this. First of all, thank you for this wonderful opportunity that is provided to me. And I always like to talk to young students and try to see how higher education becomes priority number one for the young students. I hope I have inspired at least one student today. My day is done with that.
Yes, sir. I think majority of the students like to come to IISc and work there. That's a dream for every one of us. And we are fortunate that we could study at IISc. Even today, we cherish every moment at IISc Science. I'm also fully aware that if we can go out and reach to anyone there, there's always help that's being extended. I think all that I would request the students and faculty is to reach out to people there, go and interact with them, work with them, obviously the whole idea is to contribute for something for the national building. I think it's a great opportunity for each one of us to listen to you and also to understand the kind of domains that have been identified and where the research is being carried out. I'm sure the participants have immensely benefited from this lecture. We will continue to keep in touch with you, invite you for specific lectures. I think you gave one lecture earlier also on game theory for social good. I think probably will be coming back to you very soon from Bytes and Diamond Sagar University as well. Thank you. Thank you very much.
Thank you very much. Thank you very much. Yeah.
May I request Professor Malagi to propose the vote of thanks?
Good evening, one and all. It is my privilege to propose the vote of thanks on this occasion of DGL. On behalf of DSI and the entire fraternity of the university, I extend my gratitude to our honorable speaker of the evening, Professor Y. Narahari, to take out his busy schedule to share his knowledge in the topic of higher education opportunities in computer science at IISc and beyond. Thank you for inspiring and encouraging us with your insights on the research areas in the area of agricultural and healthcare, etc. And also for emphasizing on the importance of strong fundamentals necessary for this research. Thank you very much, sir. Also, special thanks to our Vice Chancellor, Professor K.M.B. Murthy, Chairman Bytes, for guiding and supporting us to make the webinar successful. I extend my gratitude to Mr. A. Srinivas, Dean, School of Engineering, Dayanand Sagar University, for his constant support and cooperation. And also, I thank all the co-panelists here. So I must thank the organizing team, chairpersons of all the departments, all the faculties of DSI and other institutions who have joined for this webinar, and all the beloved students for joining the session and making this webinar session a successful one. Thank you everyone.
Thank you. I think we also thank Professor Natarajan for taking time to be with us this evening. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, Professor Natarajan, sir, for your closing remarks. Thank you so much. So
I'm glad I listened to you today, Narahari.
Fine. Thank you. Namaste. Namaste.